The steps in finding the roots through bisection method remains the same even with more complicated functions. Check out the root of this exponential function here in numerical solutions to see problems. Before delving with an example, let's differentiate bisection from the previous method first. Say that we have a curve drawn on the Cartesian plane, where the root is as indicated. When we were working on incremental search method, we actually have to divide the interval into desired increments and compute in order to know which smaller interval to use in the next iteration. Although admittedly, this method is simple, it is time-consuming, so the bisection method shortens the procedure a little bit. In this approach, the concept is to cut the interval into half and totally disregard the irrelevant half. So we take x of 0.5 and then drop the first half as the root is found on the second half anyway. The exponential function for this example is 2e raised to 3x less 2e raised to 2x minus 5. We look for the positive root nearest the origin, and we stop upon reaching 3 decimal zeros. The initial value should also be whole numbers. Generally, start by looking for the interval according to the instruction. We use a positive assumption nearest 0, but we can also use 0 for a start. Plug this into the equation to have 2e raised to 3 times 0 minus 2e raised to twice of 0 minus 5, giving negative 5. When x is 1, the function becomes 2e raised to 3 times 1 minus twice of the Euler's number raised to 2 times 1 minus 5, which results to positive 20.393. With a sign jump, it is advised that you still take a minute to illustrate the interval. So in the Cartesian plane, at x of 0, y turns out as negative 5. Then when x is 1, y is positive 20.393. So the curve may look like illustrated. To start off with the bisection method, tag the limits. That's negative for x of 0 and positive for x of 1. Then bisect the interval. So take half of 0 plus 1, which is 0.5. Have this placed into the function and get twice of e raised to 3 times 0.5 with negative 2 of e raised to twice of 0.5 minus 5, which then turns into negative 1.4732. With the illustration of the midpoint, it is clear that we don't need the first half of the interval. Thus, it will be disregarded, and the new left limit is x of 0.5. Let's create a table in iterating the root for the function. Using the bisection method, we only use the columns for the left and right limits, another column for the midpoint, and the y value of the midpoint. From the computations earlier, we have identified the preliminary interval of 0 for the left and 1 for the right limit. Their average is 0.5, and the function of the midpoint is negative 1.4732. Continue the table by replacing a with c. This is because f of c turned out to be negative. Take note that a negative f of c replaces a negative limit. A positive f of c replaces the positive limit. Then b is only carried down. Next is for the midpoint, taken as half of 0.5 with 1, which makes 0.75. Place this into the function and get 2e raised to 3 times of 0.25 minus 2e raised to twice of 0.75 minus 5, giving positive 5.01209. The next iteration starts with the placement of b with 0.75 as f of c is positive. A is still 0.5. Compute for the midpoint with half of 0.5 plus 0.75, which is 0.625. Have this as x in the function, which makes 2e raised to thrice of 0.625 minus 2e raised to twice of 0.625 minus 5, giving positive 1.06095. Still far from 0 with the accuracy required. Continue with the next iteration, where positive 1.06295 indicates that b is replaced by 0.625, and a is still 0.5. Their midpoint then is half of 0.5 and 0.625 added together, giving 0.5625. The function of the midpoint is 2e raised to 3 times 0.5625 minus 2e raised to 2 times of 0.5625 minus 5. This results to negative 0.34854. Finally, we are in the decimal. Continue with the iteration. Check f of c as negative, so c replaces a. b is still 0.625. Having both a and b, we take the average to have c, which is half of 0.5625 plus 0.625, resulting to 0.59375. Have this plugged into the function and have 2e raised to 3 times of 0.59375 minus 2e raised to twice of 0.59375 minus 5, which is simplified as 0.3168. Let's take the first decimal zero by iterating again, and by the sign of f of c, we replace b by 0.59375. A remains with 0.5625. Their average is taken as half of the summation of 0.5625 and 0.59375, which is 0.57813. The function with x plugged as the value is then 2e raised to thrice of 0.57813 minus 2e raised to twice of 0.57813 minus 5. The function becomes negative 0.02522. For the seventh iteration, a is replaced with 0.57813 because of f of c as negative. b is still 0.59375. The average of a and b is then 0.58594. And the function then becomes 2e raised to 3 times 0.589594 minus 2e raised to 2 times 0.58594 minus 5, which becomes positive 0.14345. With positive f of c, c replaces b, and a is carried down. Take the summation of 0.57813 and 0.58594 divided by 2, which becomes 0.58204. Have this substituted in the function and take the result as positive 0.05858. This value shows that we are near the second decimal zero, so we keep on iterating. As f of c is positive, c replaces b, but a is still 0.57813. Have the average with half of 0.57813 plus 0.58204, giving 0.58009. The function when this is plugged becomes 2e raised to 3 times 0.58009 minus 2e raised to 2 times of 0.58009 less 5. The function then is positive 0.01664. The next iteration will have the same procedure. With f of c as positive, c replaces b. Then a is still 0.57813. The midpoint is then half of 0.57813 plus 0.58009, giving 0.57911. Plug this average into the function to have 2e raised to thrice of 0.57911 minus 2e raised to twice of 0.57911 less 5, resulting to negative 0.00422. Now that we have two decimal zeros, a few more iterations to have the root. With negative f of c, c replaces a of 0.57911. b is carried down as 0.58009. The average of both columns is 0.5796, and when these values plugged into the function, gives 0.00626. The last updated function of c is positive, which means c is replacing b with 0.5796. A is taken as 0.57911. Then add these two together and divide the summation by 2 to get the midpoint of 0.57936. The function of c then becomes 2e raised to 3 of 0.57936 minus 2e raised to 2 times 0.57936 less 5, which becomes positive 0.00102. The next iteration then starts with c replacing b of 0.57936. A is still the same. C is then half of the summation of 0.57911 and 0.57936, giving 0.57924. F of c is then 2e raised to 3 times of 0.57924 minus 2e raised to twice of 0.57924 less 5, which results to negative 0.00155, still two decimal zeros. Let's iterate another step with c of 0.57924 replacing a, and b is still 0.57936. The midpoint for this small interval is from half of 0.57924 plus 0.57936, which is 0.5793. The function of the midpoint is then 2e raised to 3 times 0.5793 minus 2e raised to 2 times 0.5793 less 5. The function then is negative 0.00016. This y value qualifies with the requirement of 3 decimal zeros, so we can then finally take the root of the function as 0.5793.